Very welcome also from our side, Team Geosphere Austria. My name is Yasmin Markl. I have my office in Salzburg, and my colleague's name is Andreas Wirth. He is sitting in Vienna. I will start this weather briefing with a short overview about the weather in Europe and also give a very brief outlook for the next days. Afterwards, Andreas will continue with a more specific topic, a very winter weather related topic, let's say. I want to start. Okay, I want to start, but my arrows don't work. Yeah, I want to start with the Airmass RGB satellite imagery. The Airmass is a very powerful tool, especially for analyzing the dynamics of the atmosphere and especially for upper levels in the atmosphere, because it involves both water vapor channels and infrared also. So it is less powerful or more or less unuseful for very low level structures or ground features. There is one task for you to wake you up from your lunch break. Please use the annotation tool, and I want you to find areas where you expect high level thick clouds. Maybe some more, because I think it's really, yes. Thank you. That's enough. It's, in my eyes, something quite easy to find, especially because, well, yes, the color of high-level thick clouds is white or very bright, and you even see structures of the cloud, so it's quite easy to identify. As I have said before, lower features are not really seen in this imagery, but we will come to other products soon. Just quickly to talk about the weather situation over Europe and what we can see on this image. I have also put the geopotential on top, and now we can really nicely see the movement, basically. So there has been a high pressure system that was really dominant over Europe the last couple of days, weeks, maybe even, that is now moving to the east. And there's another trough here. And especially, I think, for the next days, important or interesting is this system, which is a frontal system. The warm front already crossed parts of Europe, the cold front still out there, I guess, and another system that lies between Great Britain and Scandinavia within, well, clouds and an occlusion, but probably already decaying. Yes, so there's this frontal system, and we will come to that now in another image. I have chosen the dust RGB because dust RGB is always a very powerful tool. It's also to use day and night, and here you can really nice see the higher clouds and also other structures that lie below and closer to the ground. I have another exercise for you. Please try again to annotate and find areas with low level stratus or even fog on the ground. And I'm sure you will find some areas. So yeah, not looking at the high reaching clouds this time, but on really low level features, fog on the ground, low stratus. I have already one guess from a guest. Okay, over Britain, yes. Oh, very. Okay, I think you get the point. And yes, it's also my opinion. Okay, that's interesting here. This other circle in the west over the Atlantic. It is actually the very bright. Okay, thank you for annotating. You can stop. It's the yellowish color basically. And so we have it on many areas at the moment, also in combination with a quite well-pronounced inversion at the ground. So dust, not dust, well, dust could also be seen, of course, in dust RGB, but now we are talking about low-level stratus or fog. And this is also very typical for this time of the year, of course, and especially after such a long period of high pressure. One thing I wanted to show you on this image that has been more or has been better visible the last days, so I'll try to make it visible also here, is if we look at cirrus clouds, so kind of the opposite of low stratus, high ice clouds, cirrus clouds, very thin ice clouds. We can see them on this image. We can see it with this greenish, or here it's very nicely seen with a almost black color, or also here. And this greenish color here, so when cirrus is a bit thinner, it can be very confusing if you have so much fog on the ground or low stratus, because if low stratus is very thin, it can also become green. And that's something you should have in mind if for example, if you are looking for fog in your area and you don't see the whole structure, the whole weather situation, it might be confusing. I would suggest for this to switch to the 24 hours microphysics RGB, because here cirrus is black to bluish, and that's a much better difference and easier to distinguish in cases when you have so much fog on the ground. Here you see the blue color of the cirrus, and here it's more blackish. All right, talking about fog, I'm showing the fog RGB. The fog RGB is really nice to see fog on the ground, and it's with high resolution, so that's very beautiful to look at. I want to emphasize the snow on this picture. Snow is a topic every winter, is a topic also this winter, and especially because it's at the moment quite rare. We don't have so much snow, and so I was wondering what is the best product to see snow cover on land. Yes, the fog RGB is quite good, especially here. You see the Alps very well, you see the shape, but sometimes fog has a very similar shape because it goes into the valleys, and then it might be harder to distinguish than on this image. And by the way, don't be confused, it's an image from yesterday, because today it's more cloudy and not so nicely visible. I looked at other images, satellite images, that also show a good contrast between clouds and surface features and fog. I also found the day microphysic RGB to be quite useful, because here also snow has a quite different color than than fog and then the other clouds and high-reaching clouds, but sometimes it can also be similar. So still not perfect and also not in high resolution. And then there is this special snow RGB, and I think this is a really cool tool to visualize snow on the ground, of course, only if there are no clouds on top. So if you have a free view down to the surface. But this is really nice because snow on this image has a very unique color. And I would suggest if you're looking for snow, to switch between different products, and if you have the possibility, of course, to make a time loop, and then probably you see clouds are moving in snow most of the time not. Yes, speaking about snow, I just did a very quick comparison between this year and the years before. This is 2025. And also the day microphysics RGB snow would be would be the pinkish color here. You see it much better on the image from last year. Here we have so much more area that is covered by this pinkish color, so snow on the ground. And also 2023, there's much more, especially also in the east or over Scandinavia. Also 2022 was more at this time at the year. So yeah, exciting how this winter is going on and how how we will how snow will if snow will come. That brings me to the last part of my presentation, a very brief outlook for the next days, of course, not weeks. And we start this outlook with today as with ECMWF weather charts. We have on the left-hand side geopotential and temperature at 500 hectopascal, and on the right image it's equivalent potential temperature. So we see this frontal system here with the cold front and the warm front that moves to the east, so bringing more warmer air to south of Europe, and following a cold front that is going to be exciting maybe tomorrow. Here's the cold front, because it brings wind, but it also brings precipitation. And then there's the question, what will be faster? If wind is faster, it probably blows away the cold air on the ground before precipitation falls. But if precipitation falls into the cold air and on the freezing ground, there might be the risk of freezing rain and slippery surfaces. So be careful tomorrow when the front comes in. Anyway, if we go on, we see that quite quickly there's another frontal system, especially with much more warm air that comes to many regions of Europe. And this is already now the weekend, Saturday and Sunday, where the pressure gradient between south and north even deepens. So in alpine regions, there's also the chance to have some föhn wind conditions. And that's actually also very interesting for January, because it even it brings even warmer temperatures with the föhn effect. If we go on a little bit, this is now Sunday, and there is another small system that might bring precipitation over Italy and the Balkans by the beginning of the week. And then there is this huge, massive system, this low pressure system that is in the north, and I'm very excited what it will bring in the beginning of the week to us in this well-pronounced westerly flow. And so not more about that. We will see how it develops, and this is now my time to hand over to Andreas to continue. Thank you very much for listening, and maybe hear you in the end.
So thank you, Yasmin. You introduced already the topic of snow. And I have to say that I'm quite happy that there is no snow this year in Vienna, because snow in Vienna is always fun only the first hour, and then it gets very dirty and it's not a place to enjoy anymore. Well, yeah, the second part of the weather briefing will be industrial snow. So snow again. It's also called chemical snow. And we had it this winter already 3 times. It's a quite rare phenomenon usually, and it doesn't happen very often. But this year, alone in January, 3 times is, I think, a record number. What is so special for this industrial snow or chemical snow? We had a very strong event with about 3.5 centimeters of industrial snow in Vienna, which is really rare, that amount. Usually it's only a few millimeters. But on 1st of January and it started in the night on New Year's Eve. We had this industrial snow over Vienna, over parts of Vienna. And you see here the weather chart of midnight, so the very first minutes of the year. And this is not the typical situation for snow to fall, because there are no high clouds. The pressure indicates a high pressure area over Austria. So this is not typical the synoptic situation where we would expect some snowfall. However, there was snowfall. You see it on this image from a colleague. He made it in one of the areas that were especially affected in Vienna. And you see on this park bank that there's few centimeters of snow, and there were even enough snow for children to build snowmen. So what do we need for the formation of industrial snow? And here are the ingredients all around this snowflake, but one of them is not really needed. And it's up to you now to find out which of the ingredients is probably not essential for the formation of industrial snow. Okay. Yes, that's correct. So we have often the situation that it's in fact a regional snowfall event. It's not over larger areas. And this is due to the generation process, how it is formed. And you will see that the ingredients are, among others, the abundance of aerosols. And the aerosols are emitted from industrial plants. And we need that. We need other meteorological ingredients too, like temperatures below zero. We need some humidity, of course, and we need a stratus layer that is combined with the capping inversion. So let's have a look at the ingredients. But nighttime is something that is nice to have, yes, and I will tell you why, but it's not absolutely necessary. We can have industrial snowfall also during the day. So let's have a look on the temperature, vertical temperature profile. You see that we have a strong capping inversion at lower levels here around 960 hectopascal, which is quite low, but typical for a winter situation. And what is also striking here, you have the comparison between 11 or 12 UTC and midnight, and you see that the inversion is a little bit sinking, so that the cold air pool in the lower levels is a little bit smaller. It gets smaller with time, which is often happening in the night, of course, where the inversion sinks. But this has a secondary effect that the pollutants are emitted, of course, in this cold air pond here on the ground, and they have even less air to dissolve, and so the concentration of the pollutants, of the aerosols, are higher. What we also find, at least for the Vienna situation, is that we have a low-level wind, which is not too strong, not too turbulent, a little bit turbulent, but not too much, coming from the southeast, striking over some humid areas like the lake, the Neusiedler See, which is on the way towards Vienna, but also the Danube brings some additional humidity to the lower levels. So for snowfall, we need humidity, but this humidity is kept under a very strong inversion that is stronger than 10 degrees. This is an ECMWF chart. We have a very high humidity, relative humidity. Here the chart for 1000 hectopascal, but you see clearly that in the eastern part, the flatlands, we have high levels of relative humidity, which is absolutely needed for this industrial snowfall. So the process is known. We have some industrial plants in Vienna, in the surroundings of Vienna, and they emit aerosols into the atmosphere. And since the inversion is not very high, the air is polluted and the concentration of aerosols gets higher, mixes with the stratus layer, and then these additional aerosols act as condensation nuclei, and snow falls out of this thin or more or less thin, sometimes thicker layer of stratus. So the case here, 1st of January or the New Year's Eve, happened on the other side of Vienna. So our institute is here in Heiligenstadt, and here you have the Danube. And this is not the exact map, it's just a round circle where the snowfall was strongest. So I heard from some of my colleagues that Floridsdorf, this part here of Vienna, was not so much affected. It was more the 22nd district here around this part, and some areas near the Danube were not so much affected. It was more this area. So there are some industrial plants in Vienna. One of them is here. These are energy plants. They produce heat for the heatings, transform gas or mineral oil to heat, and yeah, this is delivered to the houses. So, but they emit also aerosols, and they are, as you have seen, the wind comes from the southeast, is directed then towards the northeastern part of Vienna. So this snow is a little bit different from the snow you usually experience. Yeah, it is very sticky. It is consistent of small ice needles, and since it is so sticky, it's not only on the upper side of the branches here, it's also on the lower side. They consist of needles because there is not much time to grow. They cannot stick to one in another. They fall down and attach on the ground on everything that is on the ground, on branches, on the surface, on cars, on everything. But on parts where usually also, which are hidden a little bit from the normal snowfall, they can attach to parts where that normally are not the ones where the snow gets in. And what is also very interesting is that the concentration of aerosols is higher, and these aerosols are not the healthiest ones. So the pollution, the degree of pollution of the snow is higher. So it's not very good to drink it or for children to take it into the mouth. So there are some cliches now from that event. So you see everything is covered with snow. This was, of course, an extreme event. We had it twice in January, then later on with less amount of snow, but here you have some images. This is very unusual to have this high amount of industrial snow. So these are colleagues from my colleague, the photos that he made from his home. In my part where I live, the snow was not that abundant. Yeah. So thank you very much. That was just a short excursus to another type of snow. And I hand back to my colleague, Yasmin.
Yes, thank you very much, and thank you for this very interesting topic. I just want to announce the next weather briefing that will be in February, and the Portuguese Institute for Sea and Atmosphere, IPMA, is in charge of it. The date and the time will be announced, so just check it out on our website, EUMeTrain.org. That's it. Thank you very much for listening to us.